You're live.
The name tags.
Oh yes, we should have everyone grab their name tags. Or Justin, if you're really good at names now, you can hand them all out to people.
Let's see. I think I know. Let's see. Can you tell whose name is who, Justin? One down. One for one so far today.
One. You gotta get four. You gotta get four right.
Okay. Grab someone else right here. I can't say his name. He's got two. My 2 for 4. 2 for 4. Halfway there.
Same on got help me.
Yeah. We just gave it to Kate over there.
And Ryan.
Right.
All right.
Score 2.
Let's see. Well, I know Casey isn't here, so all right. Good that you know that Casey isn't here. Catherine. Oh, he's 3 4. Very nice. It's gonna be a really hard last one. He's
Yeah.
He's got one left.
I'm gonna get these guys out of here. And then here, Justin. Very good.
All right. Feel free to feel pretty good about that now. So, using our tools and okay, yeah. So we're gonna be doing more on Atlas today with our relationships, and I can't read that. Patterning. Okay, got it. So next slide, please. So we're gonna have CAD launched and downloaded all the files because you happen to probably be here for a while. Half of CADing is probably uploading and downloading CAD.
Just like saving, you gotta do it, otherwise you will be not happy at some point.
Hey David,
Yes.
can you tell everyone to log in this?
Oh yeah. Okay. I'm just since they're kind of like on live stream, I'm just gonna type it in.
Yeah, that makes sense. We can have the world hack it. Why don't you want random people signing in? Just delete every file.
Just start like making random files. Just start putting random parts on a robot.
Just upload a virus. I will
You guys
take
are
down
talking
the
so much, I can't
CADlab.
remember what I've typed already. Okay, that should be working.
I shall take down the CADlab.
And your name tags.
Good job. All right. Are we good? Is everyone?
Well, can we get thumbs up if you downloaded from CADlab? Oh, yeah, sure. I just can't type it out here.
Where is it?
Very good.
Okay, with the CADlab.
Hello.
All right, so we're gonna be CADing this plate. I don't know. Hey David, is it all right if maybe we take a visit to Happy Gear sometime today and look at this for ourselves?
Yeah, if you want to, we could just do it right now. I suppose we can have everyone back. Well, we are really tight for time, actually. We'll do that at the end.
All right.
So you can see it at the end.
Okay.
Extra quick.
So we did a lot of this stuff, basically 4 steps: draw, define, dream, draw, define, and then dimension it. There should probably be like another one, like maybe together. So next slide. So we're gonna plan it, and then we're gonna extrude it. So this is a pretty complex shape, actually. Probably gonna need a little help from David. Cutting this a little bit because this one is actually a little more confusing. So after it's all defined, add lightning holes, because if you're especially Rat Pack, we like to come very, very, very close to hitting the limit when it comes to robots. This season we were 119.5 in that range. So we had about 0.5 pounds to work with.
And we use it.
Yep. Yeah. Okay. The pins on our bumpers will put us over. So yeah. And so then we'll put some more lightning holes down here for his weight.
open a new part if you haven't. So let's file new part. Start a sketch up here. What line?
Right. So, right.
Ah,
So, pretty straightforward. Draw lines and arcs. I'm pretty sure we went over all of this. Arcs. Yeah. Sure.
So make
So-
sure to draw those specifically and get it roughly in this general shape of Atlas. So make sure you draw those 4 lines in the bottom and the 5 arcs. And make sure that they're kind of roughly in this shape. Doesn't matter if they're exactly right in all the proportions, but
So-
just copy it best you can.
So I'm gonna jump back and forth, so you guys can watch me do it. I'm gonna start with 4 lines here.
And before you get too far, make sure you define the first few lines to the origin. So the bottom left corner should be right where the origin is.
I'm going to switch to inches. Should be the bottom left corner. is the origin.
Did we use inches this year, David, or were we both little engineers and use the metric system?
We used inches. I'm sorry. Every year I keep wanting to change to the metric system. There's always another reason why we don't. At some point, we need to make the switch. But the majority of first components, surprisingly, are in inches. Sims are 2.5 inches in diameter. It's like hardly.
So if you guys need something or see this, let me know and I'll switch back to it.
Very good. Well, actually, move the whiteboard over here. I can sort of roughly.
Yeah.
That would be helpful.
So let's see. Time to bring out my very artistic skills.
It's all right. You're better than most than me.
Don't have a beret.
Happy little clouds. This. Everyone.
To be fair, this is like half my architecture to like half my closet, so
And how many shirts do you have?
like 4. I don't even know how, but
How
I
did you
have 4. I think so. I think one of them. See, I got one extra one from the season. I got my 2 normal ones for the season, and then I don't know how, but I think I have one of Yu's from Lakeview that I think got mixed up. So this is kind of what it should look like. I don't know how well you can see if it's colored as well, but
Get this close. And perfection definitely is not a goal yet. That's why we have CAD to put in all the numbers.
Mine is perfect right now.
Beautiful. That would be.
oh, if you want to exit out of the thing, just press escape and it'll exit out of the what you're using. Do that.
This your CAD file on the big screen here. I see that there are two dots down here where they should be merged. If you zoom in down there. After a while, you develop an eye for these things. So you want to make sure that all your points are converging. Looks very good. So we should have 5 arcs, 4 lines. Oh, it takes making that less.
Well, I need from this try. It's making me feel bad. That's pretty close.
Yeah.
So maybe small ahead, but. So how are we doing on this? Can I get a thumbs up on who's done? Okay, we got 1. Okay.
Have you guys been using the Legos before?
No.
Okay, well, there's a Lego system. What I like to use is once you've completed a really big step, I'm going to take some of these bigger ones away. Well, everyone can do a big step. Once you've completed a nice big step, everyone gets to choose a base right now. Then you get
Extrusion. Extrusion.
I think you might want to share with a friend there.
Here, Catherine. You're gonna have a good day.
Then I'll just come around, and when you guys get to big checkpoints, like I see you've completed things, then you can go ahead and take a nice big handful. And I reserve the right to award and take away Legos.
Take away. I
Yes.
remember this when you taught me.
Well, you were well behaved.
Oh, that makes me feel better.
Let's see. Okay. So Cade has a question. He was saying, how can we?
I got
How can we delete some things? Cade tried deleting a point, like the center point of one of these arcs. When you right click on a center point of the arc and you hit delete, it will give you a message that says sketch endpoints cannot be deleted. It's because they're just this one-dimensional thing, and if you delete that, the circle always has a center point, and you can't delete a center point of the circle. So that's just what that error is about. If you wanted to delete a circle, you have to click on the actual ring of it. Back. And that's why we have Control Z.
Our best friends.
So right click on the circle, and then right click there, and then go.
Right.
How's it going? So we've got one of those arcs. Let's go ahead and jump into the arc code rather than on straight line. See if we can draw a second arc that starts from that one. It might be easier to use.
Oh man.
It might be easier to use. It might be easier to use this third option there. That's a 3-point arc. Will start at one end, and then it'll end at the other end, kind of like you're drawing a line. Again, somewhere in space.
I sort of see like a face in that almost. Like
And you can drag that out.
here's like the eyes.
Teach me
Yeah,
yellow.
yeah.
Very wide eyes.
Do that same process a
Then
couple
like
more
here's some
times.
sort of
Don't worry about what they
oh we pull it back. Hey, it's like the rat pack
So-
almost. Except the elephant.
So let's draw that.
What's
on
up?
the first one. Isn't it? What's the image?
Yeah, a little bit.
Let's go ahead and draw another arc. We gotta draw 3 more. And as soon as you draw 3 more arcs, we'll be set to go.
Guys, this totally not look like Atlas.
It's both.
With your shadow. But first, let's take a selfie.
Oh, don't worry. I'm so at least like probably the worst. I got one of those for like 2 years ago. I used to like one because I couldn't figure out how to. I have like the annoying Bluetooth one that like never works.
2 more arcs, and then we're all finished.
Let's go. Does everyone else at this point?
So if you've distorted your atlas to make it look like something that's not an atlas, go ahead and get it back to the general shapes where it's supposed to be at. You can Control Z, and we want it to look something like this. As soon as you put that point back, you have to Control Z a little bit too much.
I think I could fix that.
You have a point down there in the detail thing. Yeah, I did that one too. Okay. Very good. And as soon as it's back in that good atlas shape, we're ready to keep going. Okay. Go ahead and take a handful.
All right, we're here.
Now
Now
we're
we're
at
at
This is next, right?
So we've drawn all of our geometry, and now we're ready to start defining it.
All right, next slide. So sometimes SolidWorks will do it for you, kind of helps you out to make them horizontal and vertical, but if they aren't, put them on these 4. See, these are all nicely defined. You got your 10 pixel icons that show you've done that.
Looks like everyone's got them. Very good.
All right then. And we're going to be learning a few different relations. Coincident, we've already done a little bit as David's sophisticated way of saying, don't make my fist coincident with your face if you want to sound tough.
Did I say that?
Yeah, remember that?
No. Okay, keep going.
Or if you want people to sit down, you just yell at them and say, "Make your butts coincident to your chairs."
That'll work.
That's another thing. Concentric, basically you put a circle inside of another circle. And then tangent, just basically just touches it at one point and then goes off to wherever it's going. So
So here's some examples for tangent. So we've got some of the purple ones that are tangent, and then the grayed out ones are close, but not, those aren't tangent. So you can see here, tangent kind of is aligned by that super smooth transition between arcs. So it'll go from this nice clean line, and then it'll very gradually go from an arc, versus this one has a kink. It's kind of hard to see with the pixelated projector, but it's got a kink right there. And then the same thing over here, where it easily transitions between these 2 arcs, whereas these are kind of overlapping like a Venn diagram, or they might not be touching at all. But these would intersect at just one point right there. And that would be what tangent's all about.
this is going to be a little bit more confusing. So you want to make these 2 arcs tangent. You want to make these 2, and then these 2 tangent.
Exactly.
This one tangent.
Right.
This
So-
one tangent is this one going to have like an invisible line that went up.
That's exactly it. So wherever you see those 2 color pairs, that'll be what we're going for. So we'll start with the one that was yellow on the screen. Go ahead and grab the pot belly of Atlas and make it tangent to that vertical line.
So for this one, I kind of just explained it. Basically, act like there was an invisible line right here. You're going to make that invisible line tangent. So it's like that. It's pretty much neat.
So you guys know how to do that? So you select one line, and then with shift, select the other line. And when you let go of the shift key, it brings up this upper left that says make tangent. So you click that, and then it puts that little icon there and makes it tangent.
Very good.
Any questions?
Looks very nice. Let's go and do the second one.
And be careful, because other options might
Hold on.
pop up.
Careful. This one, you don't want to make tangent.
You don't.
This one has a sharp point, and that's part of that curvature of Atlas. So that one we want to keep as a point. So don't make this this yellow arc and this orange arc tangent. This one should be left sharp point, but you can do the rest of these. And if you've made them tangent, you can click on that tangent icon to add it. It's looking very, very good. take a look at it on the screen here, we just simply added a tangent. But it distorted our geometry a little bit much. So,
Or did it just actually make another circle?
so it didn't make another circle, even though it might have looked like that. But what's going to happen is when you're adding tangents, the SolidWorks is going to make this circle this arc here can be tangent with this one in one of two ways. It can the arc can bend backwards and make it tangent, or it can bend forward and make it tangent, make it kind of smooth up here, or it can kind of curl back. So what we have to do in order to specify which way we want, we have to move the geometry. This is kind of the key point. Move the geometry so it looks approximately like you want it to look like, and then as soon as it is that way, then you let go and then you add your you want help there? Okay. This is psychedelic.
It's like KSP physics. It's like whenever
Okay,
you
I
try to
zoom in there, you might be able to get it. Yeah, you'll be able to get this one. So now it'll be able to force it there and there.
It's like KSP because you try to like get into orbit around something, and unless you get it like perfectly, it starts spinning around and making more random circles and everything you can see.
And then you just go.
Yes, those should be tangent. The second one. Go ahead and you can add more. Oh, I can't stand too close to the screen. It kind of makes me feel dizzy.
I like it. Yeah, I think it'll work.
Zoom in. Can you?
My tangent.
Okay, yes, that is tangent. When you hovered over it, it showed you that both arcs were tangent.
So it'll work.
This one will work.
How's everybody else? You guys hopefully get it easier.
Go ahead and jump back to the slide too. That way we can see it all.
Yes, this one. If we make these two tangent. Okay.
Yep.
Just making sure.
We double check that on at least on this computer, yeah.
Then.
And what you can do is you can hover over the tangent icon that it'll place on there, and it'll illuminate what curves that tangent's acting on. So you can kind of go over all the relations that you've added, just to make sure that they're all doing exactly what you expect. But it's looking very good. Go ahead and take some Legos. You got all thumbs up over here? No, no connects. That's from Transformers kit. Forever and that's how.
Okay, I'm like, this looks a lot like Connect. That's why there's this rotating piece. Okay. Yeah.
Five arcs and 4 lines. Okay, let's go ahead and jump to the next part. So we just learned all about tangent, makes those smooth lines. So the next section is all about concentric. So in this simple example here, this one arc here is centered on the circle, but when they're not concentric, you can see that it's just not centered, and this gets really thin and this opens right back up. But you can shift this so that they share a center point. Each one of the arcs shares a center point. And then those things will be concentric. So go ahead and let's create these two pairs. We're going to add two concentric mates or relations.
This yellow one, and this yellow one, and this orange one.
Correct.
It's basically we're trying to get them to kind of curve in the same way.
Exactly. They're following the same rules, following the same code. So the concentric. Oh boy.
Uh-oh.
Sounds like something fun happened over here.
Whoa!
Oh no, it looks good. Atlas just went on a diet.
What Atlas? Why not some extreme diet right there?
I think that might be a little bit unhealthy. So in the case that your Atlas distorts a crazy amount, what you can do is you can click and drag it back into shape. And you can add a little bit of meat to your Atlas. Give them get him back to where he's supposed to be. And
Yeah.
Break it.
that one's looking really good. And what I'd recommend too is you can try clicking and dragging on the points to move them around. For instance, on the display, what I would recommend is make this arc up here bigger. Take that end point and click and drag it up and around and kind of try to shrink that other arc. Yeah, very good. Perfect. Cool. Got them both concentric?
So you want that one? Oh, there's two supposed to be right to my sketch.
Oh, what it's trying to do, yeah, you just have to shrink that. Take this point and you drag it up and around.
And for the sketch.
There we go. Now, how many different times it'll be okay. I just need a little help getting there. Okay, look at this. It looks like a worm. Cool. So how's it going with all these concentrics?
It's not good.
Not going well. Okay.
Let's see.
Show me what you got here.
Well, when I add this concentric, this happens.
Oh, that's delightful. Well, I think it's actually okay. Would you mind if I took the mouse for a little bit?
No.
Just wanted to.
Yes.
I've
Oh my. Oh.
so what I'm noticing here is that this one, that kind of the head, if you will, is quite large. So I'm going to shrink the head just by dragging that circle down.
Okay. Atlas just went on extreme diet.
Yeah. And then we
Okay.
can click and drag this end point up. Whoa, wow, that's really fun, huh? It's kind of a dance. Like maybe a little bit of that, maybe not too much. And you just got to be careful with it. As we define it more, it'll be a little bit less dirty. Also, this one wants a tangent between this one and that one.
Oh.
So go ahead and add a tangent. So you can have a lot of fun with relations. You can kind of see already. If you want a good time and you're at home alone, have no friends like me, you can pull out SolidWorks and you can have a blast. It's like a puppet show, but better. All right, let's keep going.
Yeah, so you'll probably use, one thing you can use concentric for is to guess circles, because one thing you can do is, on our robot, we had, one of our designs was having like a bunch of gears, and little Justin, freshman Justin, his first project was literally just to stack a bunch of concentric and tangent gears to each other, and then use this fancy software that turns circles into gears. So it's pretty useful for that. So actually making gears is actually pretty easy as long as you know these two.
So those are helpful. So let's learn about coincidence. I think we've touched on this a little bit. You get it? That was fun.
Oh, yeah. So, as over here, this is pretty much the one that's correct. It's pretty much concentric. No, I think I really confused.
Yeah. So yeah, the one on the left here is coincident, which means just that one of the end points of the line is touching the other. So the more vertical line here, this one, its end point is just touching this one, and it's just quite literally touching. Versus this one, they're not intersecting at all, so they're not coincident.
And so, again, if I'm correct, isn't there also an invisible line? So if we had SolidWorks, we can just like drag this out anywhere on this line.
Correct. Yep. So a point can be coincident to a line, even if it's not physically touching it. So you could have, if my finger or if my hand here was this line, you could drag it out here, and it would be coincident with this line projected behind it. So if it's kind of on the path of that line, as long as it's touching on the path of that line, it'll be coincident. Okay. So there's one coincidence that we want to add on Atlas. This is yellow and hard to see with this projector, the way we have the color set up. But you can see down here, it's that very short, tiny little line up here. That's horizontal, wants to be coincident with this sharp point that's on the right-hand side.
And so we basically just want to have our, there. So now we have our fancy line. Gonna stop with these two, so. That's the fantastic. Thinking that.
Thank you, David. I needed that.
Would you like more sarcasm next time?
I would.
All right, very good. I think you guys are rocking it. Let's keep going. All right. Checkpoint. I think this calls for Legos. So with this, we've just added all of the geometry that we needed. We learned a little bit more about relations that we're using. You're passing on Legos. It's kind of sad. I don't think we can be friends with that. Cool. So do we have any questions on what we had taken down there so far? All the relations? Let's take a look up here on the screen. This is gonna be where your atlas kind of comes to life here. We're really gonna constrain it. So Justin?
Okay, so it's a little hard to see from here. Kind of.
We'll go in more detail later. Cover. So just jump to the next slide. We're using smart dimensions to actually put shapes on things.
So this is, let's see if I can read it, 1.65.
That's 16.59. Oh, it's a big number. So we're kind of constrained to the arch's center point, that front belly center point. We have two numbers for it. So Justin, maybe you want to jot those down on that whiteboard.
Okay.
16.59 and 21.63. Let's go ahead and set down the Legos and we'll get these running.
Yeah, I'm gonna redraw atlas arms. Wow.
Let's add some of these dimensions here. Work with the Legos in just a second. So we're going to jump into this smart dimension tool that's right there. And then we're adding two dimensions. And they're going to be from the bottom left-hand lines to this point. So that's in the center of that line.
Okay,
It's hard to point with a round thing. Nice way this one. So we're going to go from this vertical line here to that one point. What? Yeah, this one. And you can drop it somewhere over here. So you see this, and that height is going to be 16. Goes from here, just makes it the origin.
So from here to
The origin.
where it says 16.59, is it, from this midpoint?
From this center point of the arc. So this arc goes all the way around this one point.
Okay.
Yeah, you can see that there in that line.
Would it be overdefined if we click this?
Well, that is a relation.
Well, like if
Or
we,
dimension.
yeah, but if we clicked it and we tried to change it, would that overdefine it?
Change what? That's 16.
The radius of this.
Oh, like currently it would not.
Okay.
But we're not gonna define it like that. So you can see how when you click and drag it, it can still change. So now we're gonna do just the second one, and it's gonna be from this vertical line. So
What?
click on that vertical line. And this midpoint. And we're just, we pretty much, what we've done here is we've added.
Teach your freshmen how to design robots. Slap some Legos.
I designed the lift mechanism out of Legos this year.
Legos are a great tool for these things, honestly.
I'm not knocking them. They would have power.
Yeah, very good. All right, let's keep going, I think.
Alright.
So we've added those first two dimensions. Now we're gonna add a second set. And the second set is just defining the box that we drew down here in the bottom. So this box, this vertical line, we're just gonna define how long this vertical line is. Say that one's gonna be 6.42 inches. And then the horizontal line that runs across the bottom, that's gonna be 13.46 inches.
Oh, geez.
This is becoming special again.
See, people think I'm really good at CAD and I can make it do whatever I want. But in reality, I've just worked with it so much, I know how to beat it into submission. And you guys are building that skill right now. You're working on how to.
It didn't kill itself.
Hey, look at that. See, look, you should be getting some black
It
geometry
slightly
now.
corrected itself.
Yeah, so is it looking more atlasy?
Yeah.
Yeah?
Awesome. No.
Okay, cool. So we got that.
Try to
really
adjust
cool. Let's
stuff.
do that
That's the lesson we learned today. Catherine still looks the best.
Yeah. Way to go, man. I like it.
Catherine's the cheater.
I think we call that skill. All right, let's go to the next slide. Cool. We've got one more set of dimensions, and this is going to be defining where the center point is for this this arc up here. That's kind of like this scoop. So it's going to be defined to the center point, defined to this left edge of, or to this bottom left edge, this bottom left corner, the origin. It's going to be defined to the origin here. So it's going to be 13.22 inches across and 39.16 inches up. And the last thing too that we're going to be putting in this one is the radius of this, the actual scoop itself. It's going to be 9.5 inches. So you can add a radius by doing in Smart Dimension and just clicking on the circle just once and then placing it.
This one?
Yep, that's the one, the inside one. 9.5. Now, if you end up getting lots of red errors somewhere around now, go ahead and flag me down, because what has probably happened is, yeah, we've overdefined it. So Justin, why don't you go ahead and explain what the overdefining is again?
I could use an example, David.
Okay.
Can you come up
Oh,
here?
yeah, you're telling me an example.
Okay.
Make an example.
So David,
Yes,
can you stand on the floor?
I can stand on the floor. In fact, I'm doing it right now.
Okay. Can you sit down now? While still standing on the floor? While standing?
Alright.
No, you're
Right?
you're sitting. No, we usually stand and sit. No. Now you're standing. Now you're sitting. See, now you're not sitting. Now you're not sitting. See,
I give up. I'm gonna turn red and just run out of the room.
yeah. So that's pretty much what your drawing's doing. It's trying to do both things at once, but it can't. So that's what happens.
It'll try to find a solution like going in the middle, but there just is no solution. So then it'll turn red or yellow and it'll get angry.
So, yeah, like that. That's the start of it. Then when it gets red, then it's bad.
Yep. So if you see that, don't fret. Just undo the change that you did, and it'll be just fine. And what it probably has meant is that there is an extra one of these green relations that we didn't mean to add. We just have to hunt through very systematically and figure out which one doesn't want to be there, which one didn't we intend to put there. And we can go through and we can fix it like that. So there's one last thing that we need to add, and go ahead and jump here, perfect. We need to add one tangent, and if you imagine this front belly of Atlas extending all the way up, this little ear on the top of Atlas is gonna be tangent to it. It's just gonna touch it. You can kind of imagine that arc just extending. So go ahead and jump back to SolidWorks and make the tip of that arc, tip of that ear tangent to the belly of Atlas.
So what's nice about SolidWorks is like you can see, and so basically arcs are basically just circles that have invisible curves to them.
That aren't completed. Yeah.
It's like, wait, I was thinking this one changed. Oh, tangent.
So at this point, it should be black, so I think we're missing one or two things. So would you mind if I poke around on your laptop? So, probably not very much missing here, but I'm just gonna click and drag around. What I'm noticing that's definitely changing is this inside scoop. So dimension that to be 9.5 inches. And I think as soon as that's done, I think it'll be set.
In place, which means, except for this.
Why don't you be on Lego duty? We got Lego right over there.
Oh, okay. It's great.
That way you can hand out all those prizes, man. It's my favorite job, honestly. To see the joy in a kid's eyes. Oh, okay, what do we have?
Just because it's
That's exciting. So go ahead and hit okay. It's just been, there's some sort of
basically, I could say this defining is basically like traveling all of your.
That's all looking really good.
Yeah, it's like a Lego.
Sometimes it's fairly personal. And it's hard to understand what's going on. So I just deleted that one relation there and. It seems like that should be fine. Okay, so I think what had happened is when we tried to add the dimension before, we must have accidentally clicked on something else. So try jumping into smart dimension, because everything else is perfect. And try it one more time. Yeah, perfect. 25. Oh my gosh. I'm sorry, I'm so glad. You know, my guess is that it's having a hard time computing this tangent. That might be a little bit complicated for it. That's just my kind of CAD intuition. If we change that to 9.5, or just unlock that one. It's really eccentric, tangent, tangent, okay. Items conflicting. Okay. Gotcha. I think I know what's going on. So this 21.38. Yep, this is what's going on. We accidentally put the 21.38 on this upper point up here when it was intended to go down here at this one. So it's really easy to just delete that one, 21. Cool. And then I think that was all that was. It's little things like that can always trip up the CAD model.
This is one for like smacking other products.
Yes. That is a scoop for carrying.
All right, very good. And I undid this tangent here because I thought it was causing problems, so we can just add that back in. I think the only one that we need to do, is between this line, the belly of it, and its upright. And then once that's happened, then I think we'll be good. Perfect.
You know, CAD models.
That's it. All right, I think we're set. All right. So the last thing that we need to do, we have our sketch, and it's perfect. It's looking very good. We have all dark geometry. So now it's time to dimensionalize it. A coin or a term that I've coined. Also, I don't know how to spell it. All right, let's go. It's not a real word, so I call it coining it. So we're gonna jump into the features tab of our command manager. So go ahead and jump there. And then we're gonna do that regular old basic streak. It's gonna be our best friend. It's not already.
Oh, so you want to make.
And that's gonna be an eighth of an inch thick. You can type in 1/8 and it'll compute it for you. Or after you get to use these dimensions for a while, you'll know that an eighth of an inch is 0.125 inches.
Should look like this.
Looks pretty
pretty close. Is it 125?
No, it's only 20 inches.
Oh, okay. All right, but it should look like this, nice thin plate. Go ahead and hit the checkpoint, or check mark. And then you'll be able to spin it around in 3D. It looks very good.
Here, I'll show you.
Gotta change it. Your tools.
All right, so let's jump into the next slide here. So good job, you guys. We got it. So we've got the complete outer profile. Let's check in and see what the next thing we're going to do is. So we're going to do the round holes next. Let's go ahead and jump into the dream section. We're going to be creating an array of 4 holes. So what it's going to look like, you guys, up here, is we've got this blank canvas here. So we're going to put one hole. We're going to put one hole down here in the bottom. And then later we're going to see how we can pattern the rest of them. So we only have to define one hole, and then we can have the rest of them for free, essentially. So let's go ahead and draw the geometry that we need for it. And we're going to create a brand new sketch. It's going to be a new feature and a new sketch. So place it on this front face of our atlas. We're going to create a new sketch on the front face of our atlas. So we don't want to edit the existing one, so go ahead and leave that sketch. And we're just going to create a new one, so that top left button. Perfect. And then you can click the front face of our atlas. Just like that. That'll be fine. You'll just, yeah, it's fine. I think we might have inverted it too or something. I don't know who's in the wrong. But as you go, you can just imagine it reversed. So all we're going to need to do to make a hole is to draw a circle. So go ahead and draw a circle. It doesn't have to be defined anywhere, and it's best if you draw it kind of out in empty space. That way you know for a fact that it's not defined to anything yet. As soon as you have dropped your circle, go ahead and give a thumbs up so we know. We got 2 thumbs. Okay, cool. Let's jump into the next slide.
David? But couldn't you also draw it on the face of it? That way you know it's on.
Yeah, we have.
Oh, right. So
Yeah.
it's off the face.
Oh yeah, right now we just drew it off the face just to make sure that it doesn't have any relations onto it.
So did we like take this sketch? Like did we like?
Yeah.
Just
We
like,
made the sketch on the actual face of the part.
Okay.
Okay, so let's jump into the next slide and see what we're doing next. So now we're going to jump into the define section. So how are we going to define this circle? Where is it going to be placed? And in the end, what we want to have it be is this circle wants to be centered in this arch. So it has equal kind of distance on either side, so that way it won't be overhanging on one of the parts or not centered inside. So let's jump to the next one. And what we're going to do that, you're going to kind of blindly follow me here in a couple of these steps, and it's going to make sense in the end. So you're going to have to place a little bit of trust in us here. So go ahead and draw a line freely in space. And this line, as a sneak preview, is going to be a geometry tool that we'll use to center our circle.
Make it for construction.
I have that as the last step, but go ahead and you can make it in construction if you want to be ahead of the game.
Why not? We'll do it for you.
Okay, cool. Very good.
So have we explained what per construction is?
I believe we have, but we'll do it again soon. So what we're going to be doing, so if we have our line, what we're going to do here, take a look up here on the graphic, this one of the ends of the line is going to be tangent to the outside arc, and the other end is going to be tangent to the inside arc. Coincident, I lied. Big difference there. So one of the points is going to be coincident to each side of the arc. So go ahead and shift select the end point, not the entire line, just the point at the end, and shift select the front face and make them coincident.
But David, wouldn't they be tangent since it's touching at one point and then just going off?
Points cannot be tangent to arcs.
Oh, okay.
Only lines and other arcs can be tangent, technically. The tangent means that it's is a line that would touch at just one point and then skim across and keep going forever.
Okay, so tangent doesn't include just go straight through it.
Right.
So real quick, so anybody wants to hear the difference or see the difference, if I select this point and select this line, I can make it a midpoint or coincident, which is what we want,
Coincident. Yeah.
coincident or make it center. None of those, it doesn't give us the option to make it tangent, because we can't do it.
Right.
But if you select a line, and this line, that one, then it gives you the option to make it tangent. And that's what, basically what this just did.
So you can see how it's going to skim across just at one point. So go ahead and undo that because we're just going to keep moving.
I think it's still.
Yeah, it's still there. Control Z one more time. There you go. And then we'll make a coincident. Very good. Cool. And the next thing is going to be making a midpoint relation. So midpoint is just like coincidence. I have to think carefully now before I speak. It's just like coincident, except it's going to, not only is it going to place it on the line, it's going to very strategically place a point at the very center, at the middle. So it's going to be a midpoint. So we can select both the line and the center point of the circle that we've drawn. And instead of hitting coincident, we're just going to hit midpoint.
Make midpoint.
Right. Okay, very good. And so this will be easier to see when if you switch back. I'm sorry, to the SolidWorks. Click and drag one of these points, the end points of the line, and you can see that our circle is not always going to be centered on our in our arch yet. So you can see when you extend it way down, it's really close to this end, and if you extend it the other way, it could, yeah, okay, never mind. But it gets really close to being in the middle. Drag it until you find about kind of like the sweet spot when it feels like it's pretty close to the center. Okay.
If you had a horizontal relation, would it always be centered in the middle?
Go ahead and add a horizontal relation
To the line.
to the line. Yeah, I know what you mean. There's going to be only one point where it's going to be, or when it's going to be in the middle. So go ahead and click and drag this around. Click and, yeah, move that down. Well, no, that is a lie. I guess that's a, technically that would be just fine. Right?
It's another way to do it.
It's another way to do it. That's a much simpler way to do it.
And it works
Until you go tangents.
until you leave the arc that's spinning.
Right, but in SolidWorks that actually can't happen. That's a much simpler solution than what I was going to have you guys do. So we're going to do that because I like that better. Thank you, Kate. I'm going to change the slide here because that simplifies things. What I was going to have you do is another solution for achieving that is to make that point always point to the center of the arc that it's on. So you could always have it be pointing at that midpoint. And then when it spins around, when it folds up and down like that, it'll always be pointing there, and it'll make sure that this is always on the center. But in this specific instance, having it horizontal will be just fine. So make that line horizontal, and we will come back to our to this sketch. Cool. Very good.
So that's great. It's geometry. There's lots of different ways to do it.
There's a lot of cool tricks you can have. So thank you for sharing your brain with us, Keith.
That's both good and bad because there's like 10 different ways you can do something in SolidWorks, and each person kind of develops their own style of do stuff. So sometimes it can get a little confusing trying to talk to each other on how to do stuff.
So clear verbal communication is key, and making sure that everything is nice and neat in your CAD files.
sure that dimensions aren't overlapping and whatnot. But let's continue on here. We have our final constraints that we're going to add to our circle. The circle's diameter is 5 inches, and it's going to be 10 inches above the horizontal line, above the origin. So go ahead and jump inside your smart dimension. It's going to be 5 inches in diameter. And then you can drag a line or smart dimension from the origin to the circle center point, and it's going to be exactly 10 inches tall. Or that distance is going to be 10. And you should see that all of your geometry has turned black. And if it has, that means you're doing very well. If it's blue or green, it probably means that you haven't stuck it. And with this, leggings. Let's jump to the next one. Construction geometry. So if we remember what construction geometry had us do, it was a very clever way of hiding essentially any reference geometry that we've added along the way, like that horizontal line. We don't want to extrude that horizontal line, so we can convert it to construction geometry. So it kind of hides it from being extruded. So go ahead and click on that horizontal line that we've added.
Not in the smart dimension.
Oh, not in smart dimension. You want to make sure that you've left smart dimension. Click on the line and check the box for construction on the left, underneath the relation window. Okay, very good. And if we have that for construction, we can jump into the cut extrude.
Wouldn't you want to do the pattern?
We're gonna do that
Is in what?
as a feature. So we're gonna do this first.
Yeah, see, this is kind of where each person kind of does it a different way.
All right, so we're gonna do an extrude cut. Careful not to do a boss extrude. That's gonna add material. I'm gonna do an extrude cut. So in this case, Dad, you have chosen the boss extrude, and you're adding material. And we don't want to add our lightning hole. That would add more weight and take weight away. So we're gonna jump into the extrude cut. And instead of blind, we're gonna choose the option called through all. Oh, you chose the right one, but this isn't construction geometry yet, so it doesn't know what to extrude. So jump out of that and then select that and hit that for construction geometry box. Very good.
Yeah, so basically, it's
Go for it.
so basically, construction geometry is basically saying that I'm only here kind of as a placeholder. I'm not actually here to show like stuff or math. I'm just kind of an invisible line that's just here kind of help out.
And it changes looks too. It's not solid.
It's hashed.
It's hashed. So there's a long, short, long, short.
All right, so if we've got our hole extruded, go ahead and let's jump to the next part. Yeah, we want to go to the Google Drive. Not this. So the Google Drive. There you go. And we're at some point later. Much later. Okay. Take one. Thank you. Have a good one. See you. It's 8:36. Okay, so we're gonna try to get through this circular pattern here. So this circular pattern is going to take that one circle that we've added, and it's gonna repeat it multiple times, as many times as we want. And so this is gonna be super duper fancy, and it's gonna save us a boatload of time. So let's jump into the features tab. We're not gonna start a sketch. This is actually gonna modify what we've already extruded. So it's a feature, and we're gonna jump into the linear pattern. Don't click the linear pattern, hit the drop down button, because there are a lot of other options. And we want to choose circular pattern within the linear pattern option.
Since everything's around, SolidWorks can get a little confused. Like, what do you want me to pattern linear? There's nothing linear in this. It's all nice curvy edges.
It is nice curvy edges.
Is everyone there?
So if we click that one button, can we get a thumbs up? Yeah.
two big thumbs up.
Alright, well, let's, is everything looking all right over here?
Oh my.
I think all we need to do is hit the extrude button. Hit the,
Challenge CADlab up and make that a robot for next year.
oh jeez.
There you go.
I don't think so. Just because of
It's
like
okay now.
that part. That
I know,
part.
these things are really kind of
That part.
obnoxious. Every once in a while,
And
it feels
this
like
part.
it's work.
Hodgepodge robot.
Alright, so let's jump over to the slides, because we're gonna explain how this works. So, what this feature is going to ask for us, it's very much like how we were using mirror the other day. It's asking us for a thing to pattern. We needed a thing to actually go around in a circle, and it needs to know what that thing is gonna travel around. It needs some sort of axis to move it around. And so these parameters here, we've got a parameter for that pivot, what the thing is going to be pivoting around, and what we're actually going to be patterning. So the first thing that we're going to do is figure out what we want to pivot around, and go ahead and click this outside kind of belly of a face here. And that belly of a face is actually going to select that face's center axis, that cylinder's center axis.
So the surface,
The surface, yeah. It should only let you choose surfaces. I don't think you'll be able to choose lines. Oh, that's a features pattern. Make sure that you've selected up here in this this first top box in the parameters window. That'll make sure that you're going to tell this is what we want to pattern around. And if not letting you select it, zoom in a little bit farther. Make it nice and big. Give yourself a nice big target. And you want to see this nice big blue streak happening, or green. That's what we're after. Very good.
Ooh. Oh my.
Very nice. Oh, that's interesting. So notice
Chicken.
what's
Oh, boy.
happening is that we accidentally selected. We've accidentally selected. We want to pattern the actual atlas figure round and round and round, but we don't want to do that. So we're going to come over here and we're going to hit clear selections. And now inside this features box, we're going to select what we want to cut, and we're going to hit the inner face that goes all the way around of our circle. And with that, we can hit the check mark.
it should say cut extrude.
Right. We want to make sure it reads cut extrude. When you zoom out, you can see that it patterns it all the way around. Before you hit the check mark, though, nope. Hit the cancel out of that. We don't want it to pattern all the way around. So if we jump back to the slide here, go to the next one. We're going to change.
How much degrees
Go ahead.
we're going to. So instead of having this, we're going to narrow it down to just this.
So in order to do that, we have to uncheck a box called equal spacing. And that will give you an option to enter what's the degree separation between each one of these. So uncheck this equal spacing box. And once you do that, very good. Yep, we only want to pattern 4 holes as well. In this system, we have 6 as the default.
Quick question, guys. If your circles are going off of your thing, how do you flip that around?
Oh, that's actually very simple. You just need to put that right there.
Oh my, it's a, I don't care. Wait, which one?
Right here.
So go ahead and type in the what's the value, degree value we need there?
20.11.
$20 right now. So go ahead and type in $20.
Sorry.
I think Cade had a situation where his circles were going underneath his atlas rather than on top. So what we can do in order to change that, right next to the face box, there is this funny little icon that has a blue arrow, a gray arrow. Go ahead and click that, and you'll see that it'll flip it to the other side. It'll kind of, instead of going up, it's going to start patterning down. And it's a very quick direction toggle. Very good. And once you have that all set, you can hit the check mark. Hit OK. Very nice. Very cool. All right, so linear pattern, we're not gonna have enough time to do that today. But I just want you guys to be aware. Let's just flip through the slideshow. Keep going.
Should we wait while you're explaining that?
That's fine. Go ahead and keep going. So, well, here we go. This is what we would have had time to do today, but we're unfortunately we don't. We would have taken this blank canvas down here. We were working with these triangular holes. And with the triangular holes, what we would have done is we would have created one set, and then we would have linear patterned it over to the other side and mirrored it up. But linear pattern, let's just jump to the linear pattern part. So we would have drawn two triangles originally and constrained them with a specific set of numbers.
And then once they were defined, you can, we haven't done all of it. So basically what you can do is you can say, I want to copy this, and you can tell it how many of these you want to go up and how many of these you want to go to the sides.
So let's jump to that section. All right, back. There. This is the linear pattern tool. You would have seen this on in your Works command manager. In the command manager, it's right here. We already clicked the drop down arrow for it to get the radial pattern, but in the linear pattern, it would be right up here. And it's just asking you, instead of where are you going to pivot around, an center axis, it's going to say what direction do you want to pattern. And you can click this bottom edge here, and it'll say it's going to pattern along that edge.
But wouldn't this be mirrored first, since this kind of took this, then mirrored it, and then pattern it?
Yeah, that's what we did. We just skipped over.
Oh, okay. So,
And then, yeah, we'd select, this is what we want to pattern across, and this is what we want to pattern. And then it went and did that and applied it. And then in order to get this cool X pattern, we created we would have mirrored it to the top here too, and we could do some fancy tricks with it. And we would have added a plane. Let's just add a plane here. I think this would be a really good exercise. So take a look up here. In a world where we had these triangles cut for ourselves already, we would have linear patterned this bottom one. So we would have taken this section and we would have patterned it to be over here. We could have told it however many we wanted. But then we would have wanted to mirror it to the top. But in order to mirror, go ahead and jump to the next. No. Yeah, in order to mirror, we need a thing to mirror, and then a thing to mirror about, or kind of like a symmetry plane. When you're doing 3D things, it needs to be a two-dimensional plane, versus when you're doing it in a sketch, you'll need a line to mirror across. So we would have needed to create a plane. Let's go ahead and create a plane here. In your features tab, there's this reference geometry button. It's a drop down. It's going to be over here close to the right of center. Right there. Thank you, Justin, for pointing it out. And choose plane from that menu. It should be the first one. And planes are cool because you can define them in a whole number of ways. The simplest way to do it is to click a face. So look at from Atlas from the bottom up. Rotate Atlas so you're looking at his bottom. Don't tell him. Don't let him know that you're peeking. And then zoom in and see if you can grab that bottom face. Make sure you click that face. That flat face. Cool. And then when you've grabbed it, go ahead and zoom out and see what it's done. By default, this plane that we would have used to mirror across is set as a distance from whatever thing that you've set it across. By default, it's set at 0.1 inches. In the case of our mirror, we would have set it at, I believe, 3.21 inches. So you can go ahead and type 3.21 as that distance. And SolidWorks has a whole series of ways to, it's programmed to be able to flip things forward and backward. So right underneath that text box that you could have put things in, there's a flip offset, which is really fun to say very fast, which will put it on either side. Flip offset, flip offset, flip offset, flip offset. Click MOSFET. Which makes sense.
The braces are messing me up.
Anyway, and so that would have created a plane for us to mirror across. You can hit that check mark. And we have a plane that we can mirror across. We have 13 minutes left today. Let's go ahead and create a simple array of holes, just like we're doing up here. We don't need to define them too much. Actually, you know what? Only do one hole. Just do one hole, and we'll linear pattern them very quickly. So create a new sketch on that top face, just like we've got up there on the screen. So go in to your sketch tab of your command manager and hit the new sketch button. And draw one hole. Yeah, make sure your new sketch tab is in here. Very good. And draw one hole and put it somewhere underneath, just like that, just like what we've got there. We can dimension that hole. Go ahead and make it whatever diameter you want. That's relatively right size. Let's do 2-inch diameter. 2-inch diameter hole. I realize when I give you guys free reign of whatever diameter you want, that could be very dangerous. I don't trust you guys quite that much with the CAD suite. Things might explode.
Exploding assemblies.
Yeah, we'll get to that soon. And then go ahead and add a dimension to the bottom left corner of the origin. Looks like on the screen we've dimensioned it to be 1.57 inches over horizontally and 1.57 inches up. And once you have that, go ahead and cut extrude that. So under features, extrude cut. And make sure you set it to through all. That way it'll keep going until it's got through. Very good. And then we'll jump in, we'll try a linear pattern out. So click on the linear pattern button itself in the features tab. And it's asking us for two things. It's asking us for a direction, and it's asking us for what we're actually going to pattern. So in this case, we want to pattern over. We want to pattern across this way. And so a line that travels that same direction would be down here. We can actually click this one edge. And so it would be traveling across this edge. And then the second thing it's asking us for, and we want to make sure that that edge is put under direction 1. And then click down here in this features and faces section. And in this first box, we can click the edge of our cut extrude. So we're in the linear pattern now. That's fine. So it's asking us for two things, what we're going to pattern and how we're going to pattern it. So this edge up here, you selected the cut extrude, that's perfect, so that's what we're going to pattern. And then this edge 1, go ahead and click on that, because I'm not sure if that's the right thing. Yeah, can you zoom out for me? Okay, so I don't know what edge 1 is, so while that box is selected, click the edge that goes across this way. Yeah, that one. Cool. And then we can, once we have those two things set, under that direction 1 menu, you can type in how many circles you want and the distance between them. So in this instance, to kind of space them nice and evenly, It looks like we're gonna want to have, if we had 5 circles, we could space them 2.57 inches apart. Very good. Go ahead and hit that check mark. Okay, looks very good. And now we can use that plane that we went to the trouble of making, and that can be our thing that we're going to mirror across. So while we're in this Features tab, click that mirror. It's to the right of linear pattern. Yeah, right there. Down, down. It's actually underneath linear pattern too, if you wanted to go that way. But you can click it right there. And once you're in the mirror, it's asking us for 2 things, very similar to how we did it before. What are we going to mirror across? In this case, our plane, because we went to the special trouble of creating it just for this purpose. And then what are we going to mirror across that plane? And in this case, it's going to be our circles. So that first circle is only going to pattern the single, but if you click on any one of the rest of the circles, it will pattern, it'll mirror over the pattern, which will be the entire array of holes.
So I selected, I cleared the selection.
Click full preview. Full preview down at the bottom. There you go.
There it is. Okay.
Yep.
I expected to see that.
Yeah. And then you can hit the check mark. And it'll plug. And you get a nice array of holes. It's the sound of brain thoughts happening.
Sorry, you might hear a little cracking and some smoke coming out from behind.
Yeah.
Cracking a little bit.
Very good. All right. So with that, I think that'll wrap up our Atlas plate. That puts all the finishing touches that we wanted to put on there.
And so, one thing we wanted to use circles, and so you want to kind of play around with them because here it kind of looks a little bit like Swiss cheese. So you might want to use a few different kinds of shapes to make it look fancier. And that's where the triangles come in.
Very fancy Swiss cheese.
That's what one of our designs look like this year. It's just a bunch of Swiss cheese, so we have some fancy cut out shapes into ours. Like getting into that logo.
So do we have any questions on how we created this at all? Cool. Well, thank you very much. This is going to, we can go ahead and jump back to the slideshow, and then we can have the proper happy script. Send us off.
Can we go visit Happy Gears?
Then we can go visit Happy Gears, yes. At the very end. Look at this. Go back one. Go back 2. There we go. So next time we're going to look into time travel. There's a time travel feature in SolidWorks. So it's going to be very fancy. We can go backwards. Okay, that's stressing me out a little bit. And then go to the next slide. And of course we knew you could do it. That was a pretty complicated part, but we got through it all. Look at that thing that you've got there. You can spin it all around. Look how complicated that is.
Now you just have about 50 more parts to do, and you got yourselves an atlas.
Yeah, the rest of them are easier though. And at the very end, as a sneak preview, you're actually going to create the entire atlas, a simplified version of the atlas robot. So that'll be what the last day of our unit 6 will be. And this actually marks the halfway point. So you are halfway to mastering SolidWorks. So congratulations, you guys.
But I want to say one thing, though.
Oops.
Thank you